Today we're continuing substitution. Here, same as we did on 4.2, we're going to be solving with using substitution. I'm going to survey my two equations here and determine which one is going to be the easiest to work with. In this case, there are a lot of options. I'm choosing the top equation, the y minus 2x is equal to negative 17, and I'm going to isolate my y variable. So I'm going to add 2x to both sides. Put my equal sign. So I have y is equal to 2x minus 17. I can now use this to substitute into my other equation. Now my other equation says that it's x plus y is equal to a positive 16. I'm going to replace the y value with this that I just solved. So I have x plus 2x minus 17, and that's equal to 16. Since there's nothing in front of the parentheses, we really don't even need the parentheses. They're just extra to keep to show that we have substituted. So I have a 1x and a 2x, which gives me 3x, combining my like terms. And then I have a minus 17 is equal to 16. My goal now is to get the x isolated all by itself. So I add 17 to both sides of my equation. 3x is now equal to 33. I'm still trying to get x isolated, so I divide both sides by 3. And I find that x is equal to 11. Placing them in my ordered pair for my solution set. I now go back to my equation over here, the y equals 2x minus 17. And I'm going to replace my x with that value there. X is now going to be replaced with the 11. So I have y is equal to 2 times 11 minus 17. So I do 2 times 11 is 22 minus my 17. 22 minus 17 is 5. My y value is 5. Let's look at example 2. In example 2, we have 2a minus 4b is equal to 6, and a plus 3b is equal to negative 7. I'm going to use the second equation this time, the a plus 3b is equal to negative 7, and I'm going to isolate my a. I chose the a because it is the one with a 1 as our coefficient. So we do not have to do any dividing afterwards. I'm going to go through and subtract 3b from both sides of my equal sign so that I can isolate my a variable. And I get that a is going to be equal to negative 3b minus 7. I rewrite my other equation, the 2a minus 4b is equal to 6. And I realize, hey, I'm going to substitute the negative 3b minus 7 in for my a variable. Goes into here. So I have 2 times negative 3b minus 7. And I have a minus 4b is equal to 6. Still at the end. I now have to distribute. This 2 gets multiplied times everything inside the parentheses. So I have negative 6b minus 14 minus 4b is equal to 6, still here at the end. Combine my like terms. I have a negative 6b and a negative 4b. So I have a negative 10b minus 14 is equal to 6. My goal is still to isolate my b, so I have to get rid of the 14. So I add 14 to both sides. negative 10b is equal to 20. I divide both sides by negative 10 and find that b is equal to negative 2. b equals negative 2. To find my a, I'm going to go back and use the equation from the first column. A equals negative 3b minus 7. I'm going to replace the b with negative 2. So I have a is equal to negative 3 times negative 2. That's minus 7. Negative 3 times negative 2 is a positive 6. Take away 7. And negative 6 minus 7 is negative 1. So my a value is negative 1. Everything here is the same as what we did in section 4.2. The main difference is, in this column, we actually have to go and isolate our variable, such as we did right here when we isolated the variable a. Solving systems of equations by substitution.